Using base 10 to determine Vortex sum of different bases. So since base 10 is the most widely used base number system and the default that most calculators are programmed with, it is preferred to find a Vortex sum of any base number system, but still in terms of the base 10 system. This is especially important since the built-in Modulo function in both Microsoft Excel and OneNote are in base 10, or pretty much anywhere you go is the default base 10. So for example, if you have 22, which is base 8, the V equals 2, this is a Vortex sum, 2 plus 2, it equals to 4. But if we have 22 mod 8 minus 1, again that's n, 8 is n, we'll have, which equals to 22 mod 7, but this equals to 1, which is wrong. So this is not the right answer because, again, this is in base 10. Since OneNote calculates the mod function base 10, we can just convert the number 22 base 8 to base 10. So 22 base 8 equals 2. We could write it again as a 20 plus 2, which equals to, now you convert it, this is going to be 2 times 10, or 10, which is going to be just the equivalent is number 8 in base 10. So 2 times 8 power of 1, or just 8, because 8 power of 1 is just 8, 10 power of 1 is just 1. So let's put that for completeness. This equals to 2 times 10 power of 1, oops, the equals auto calculates. And then this is going to be I guess this is going to be plus 2. You could also plus 2 times 10 power of 0, which is just, yeah, this just equals to 2 times 10 plus 2. So those are the equivalent. So now we just replace this 8 with this 10 with 8. So we'll have 2 times 8 to the power of 1 plus 2. This equals 2 in base 10. Again, just built in, just calculate it becomes 18. So 22 base 8 is equal to 18 base 10. So now we do 18 mod 7. It should get the right answer. It goes 4, which is right. So there's the right answer. This one's wrong using the base 10 one. You need to convert to base 10. So let's double check with a more difficult number. Let's look at 1, 2, 3, 4, 5, 6, base 7. This V equals to 1 plus 2 plus 3 all the way until 6. Again, we're adding, remember, we're adding in base 7. So we're not adding in base 10. So you can't just go and do this equals to 21, which is wrong. So we have to do it as this. So this is equal to 7 plus 7 plus 7. Well, let's look how we did that. This is base 7. So 1 plus 2 plus 3 is equal to 6. Or actually, better yet, we'll just do this. 3 plus 4 is 7. One write it in 7 because it's base 7. Let's do this again. So this is 7. And then this right here, 5 plus 2 is 7. And then 6 plus 1 is 7. So 7 plus 7 plus 7, which is again, change that into 10. Because these are, this would be in base 10 notation. So it's going to be 10 plus 10 plus 10, which equals 30, which equals to V equals 3, 0 like that. Let's put it right here. V equals 30. Actually, no, just equals to 30. Then V equals to 3. Yeah, and just remove this right here. All right. Actually, I need the space, so let's leave it back here. So anyways, so now if we do 1, 2, 3, 4, 5, 6 mod 6, which is 7 minus 1, this equals to 0, which is wrong. So again, it's using base 10, the number. So if we do this, this equals to 0, which is wrong. So, because it needs to be 3. This is the Vortex sum. So we need to convert this into base 10 first. So 1, 2, 3, 4, 5, 6 equals 2. Well, 1,000 plus 2,000 plus 3,000 plus 4,000, 400 plus 50 plus 6. Again, base 7, not base 10. And then you can write these out. This is how many zeros is 5 zeros. So we can write this as equals to 7 to the power of 5 or 10 to the power of 10 to the power of 5, but just to convert it into base 10, so it's going to be 7 to the power of 5 plus 2 times 7 to the power of 4, and then plus 3 times 7 to the power of 3, then plus 4 times 7 to the power of 2, plus 5, this is the second last one, 5 times 7 to the power of 1, plus 6 times 7 to the power of 0, just the 1. And then if you write this out, automatically calculates, 22,875, base 10. And now, if we go 22875 mod 6, which is 7 minus 1, it's right. Absolutely amazing. Now that is, look at that. Look at the size of these numbers and getting the remainder, which is the Vortex sum instantly, which is absolutely fascinating. Right, so since the base 7 number system is smaller than base 10, then the remainder, I'll just put so since that is the case, the remainder and hence Vortex sum is identical when converted to base 10 since the unique digits 0 to 7 are included in both bases, are identical in notation. Because the value is still going to be the same, but just notation as well. So, for example, if we have base 7 possible remainders, it's going to be from 0, 1, 2, 3, 4, 5, 6, and base 7 possible vortex sums is going to be 1, 2, 3, 4, 5, 6, 7, because remember when the remainder is 0, we assign it into 7. So just bold that like that. And then the base 10 unique digits is just going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but the 0 to 7 are included. So if we convert this number into base 10, we're going to get a vortex sum such that the value is going to be between 0 to 6 for the remainder, because what it essentially is doing is converting the remainder into base 10. But since the base 7 is going to be like this, it's going to be maximum somewhere in here, so it's going to be the same notation. However, for base number systems larger than 10, the remainder in base 10 can be in double digits, and larger than 10, thus the notation will not be the same, but the value will be nonetheless. So for example, if we have 19 base 16, this is going to be equals to 1 plus 9, and remember, this is hexadecimal, and 1 plus 9 is equal to A. And then it keeps going on. 11 is going to be it's going to be 1 to 9. All of a sudden, it's going to be A, B, C, D, E, F. F is the largest single digit. So that's the number right here. But 19 mod 15 equals to 4, which is wrong. In other words, so 19 mod 4. This is base 10 because it's automatically calculates base 10, which is wrong. It should be 15 is 16 minus 1. It should be A in hexadecimal, which equals to 10 in base 10. But if we convert this, so if we have a 19 base 16, then write this in our usual 10 plus 9, so 10 then plus the 9. This equals to F plus 1 plus 9. And then the equivalent of F plus 1 or 10, this just equals to 16 in base 10, and then plus the 9. 9 is included in both. So 16 plus 9, so this number adds up to 25. So if we go 25 mod 15 equals 10, which is right. So even though this is 10, it's not the same notation. This A, that's the exact one, but the conversion value is correct. They're both 10. So 1 plus 9 is 10 in base 10, but it's A in base 16. So note that since we're referring to the base 16 number system, the base 10 remainder of 10 remains as is and represents the hexadecimal number A. So we're going to leave it that when we're dealing with different base number systems, and I'm just going to leave it as a conversion to base 10. So since we're referring to the base 16, the base 10 remainder of 10, so this remainder of 10 remains as is and represents a hexadecimal number A, and we don't digit sum 10 to 1. Just bold this, so we don't, it's the digit sum, the vortex sum is not 1. It's going to be just as is. It's going to be 10 because we're dealing with base 16. So for convenience and practicality, I'll be writing all base number systems in their equivalent base 10 as shown below. So if we have base 16, if we have base 16 right here, 0, 1, 2, 3, 4, all 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And then equivalent base 10, then afterwards it's going to be 10, 11, 12, all the way until 1A, 1B, 1C, 1D, 1E, 1F, and so on. But I'm going to just write these strictly as base 10 for the most part. So in other words, this top bar is going to be just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 15. And yes, you can see the 10 right here is the A. So bold this. And then bold this. And then now we have the next one's going to be, 16 right here is the number 10 for base 16. And then so 17, 18, 19, 20, just the usual count which we're all used to. So 24, 25, 26, 27, 28, 29, 30. 30 is 1F, which is... And actually, it's not 30, because this is the number. This is 16 on top here, then this is going to be another 16, but this 10 is included in the count. So this is 16 plus 16 is 32, but there's a 0, so we don't count that. So this should be a 31. So yes, that should be right. So this should be 16 digits in both. Yeah, so 16 included is 16, so that should be correct. So 15 plus 1, 16. And then this is going to be 15 plus 1, 16. So yes, 31 right there. It's going further. So the vortex sum of the number 10 base 16 and 16 base 10 equivalent should be the same. So 10 base 16. So if you look at this one right here, so that's number 10, and then you have vortex sum of number 10 in base 16, not number 10 in base 10, but number 16. This is just equals to v equals to 1. And now if we go 16 mod, this is base 10 equivalent, 16 mod 15, and this is because, let's write this down, 10 base 16 equals to, this equals to 16. Yeah, this equals 16 base 10. That's equivalent. So 16 mod 15 equals to 1, base 10 equivalent. Just put equals and 1. Hashtag amazing. It's pretty amazing. So there's our 16 right there. Bold it. And then this is our 10. Bold this again. So yes, these are the equivalent of it. And again, just to reiterate, so this 10 base 16, it's a number, there's no 10 single digit in base 16. It goes to it goes to 9, then it goes to A, B, C, D, E, F, and the next one's 10. But then V equals to the vortex sum is 1. And we can still calculate 16 mod 15 equals 1 by converting 10 to 16. Alright, so let's continue further in this journey. So note, can calculate base 4 vortex sum using base 10 mod function without conversion. That's a note I just figured out when I was making this, the summary of this video. So consider the vortex sum of the number 1, 1 in base 8. Yeah, this is just equal to 1, 1 base 8 just equals to v equals to 1 plus 1 is 2. But then if we go 11 mod 7, which is 8 minus 1, equals to 4, which is wrong. Converting to base 10 gets the right answer, so we get 11 base 8 just equals to 1 times 8 plus 1. This is base 10. That's 1 times 8, which is our 10. And then this is going to be 8 plus 1 is 9. Then 9 mod 7, which is equal to 2, which is right. Which equals to this one, correct, right there. We can see why we have to convert to base 10 by counting up until the number 11 in both base 8 and base 10. So if we count up, so if we have base 8, we go 1, 2, 3, 4, 5, 6, 7, then we go 10, 1, 1. What we end up having is 11 equals to a factor of 7, which is just 7, plus a remainder 2. It's a remainder 2. So 7 plus 2, v equals to 2. V equals to, because it's just a remainder. All we care about is a remainder. This is the factor of 7. That's the n minus 1. So this equals to a remainder. But if we go base 10, we get 1, 2, 3, 4, 5, 6, 7, and then 8, 9, 10, 11. What the mod function does is basically finds a factor of 7 plus remainder, but now we have 1, 2, 3, 4, 5, 6, 7. Then we have 4 digits right here, 8, 9, 10, 11. So 11 equals factor of 7 plus remainder equals to 7 plus 4. This is base 10. V equals to 4, it just gets the remainder, which is wrong. And 11 mod 7 is 4, which is also wrong. So now consider the same number 11, but in base 4. So that's why it's wrong, because it's looking at a base 7, and it's not a factor of, if it was a factor of 9, we just get 1, 2, the remainder, which is correct. Now consider the same number 11, but in base 4. So base 4, we have 1, 2, 3, and then 1, 0, 1, 1. Factor of 3 plus remainder, we just have factor of 3 plus remainder. Over here is 2, so it's equal to 3 plus 2, v equals to 2, I don't know why I have so many 2's there. Yeah, v equals to 2, because that just equals the remainder. The vortex sum is just 2. And now if we do the base 10 equivalent, count, so we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 is a factor of 3, is what the calculator calculates. Factor of 3 plus a remainder. And then the remainder is going to be, well, 3 plus, over here we have 8. But this is a partial remainder. It keeps calculating, keeps repeating the same process. So we have a 3 there plus an 8. V equals to 8 is the partial remainder. Now if we repeat the cycle, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have a factor of 3 plus remainder. So we have 3 plus the 5. And then, so we have 3 plus 5. V equals to 5 is, again, a partial remainder because it's greater than 3. Repeat cycle. We have 1, 2, 3, and then 4, 5. So we have 5 equals factor of 3 plus remainder, which equals to 3 plus 2, v equals to 2, which is the correct answer. And this is all using just a base 10 counting system right there. So we can simplify this further by realizing that the modulus 3, or the divisor when you're trying to get the remainder, Yeah, and this is in base 4, is a factor of the modulus 9 in base 10, so the same factor. So in other words, if we have base 10, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. 11 equals factor of 3 plus remainder, which still equals 9, because the 3 is a factor of 9. I guess 3 times 3 is 9. It's evenly in. So we have 9 plus 2, which equals 3 times 3, plus 2, v equals to 2, which is the correct answer right there. Yeah, which is the correct answer. I don't know why it keeps calculating automatically. So 11 mod 3 equals to 2. So we don't need to convert it, because 9 is a factor of, or 3 is a factor of 9. Yes, in other words, in base 3, in base 4, 1, 1, base 4 equals the factor of 3 plus 2, which equals factor of modulus 3 plus 2. Just write that out. So we have the exact same thing. So that's going to calculate the v equals to, it's going to be 2. V equals 2 is the remainder. And then 11 in base 10, so without needing to convert, we just calculate it as base 10, equals the factor of 3 times 3, which is 9, plus 2, which equals the factor of 9. Plus 2. These are the exact same things. So 2 is going to be v equals to 2. Thus, for the base 4 system, we can calculate the vortex sum of remainder just by using the built-in base 10 mod function without conversion. So without conversion, we have 11, base 4, v equals 1 plus 1 equals to 2. And we can just write 11 mod 3 equals 2. But if we want to convert it, we'll get 11, base 4 equals to 4 plus 1, and then, yeah, this is in base 10. So this equals to 4 plus 10, or equals, make it for completeness, 10 plus 1 equals to, 10 plus 1, and then base 10 is going to equal to 4 plus 1. The relative value of 10 in base 4 is 4 in base 10. So this is going to equal to be 5, and 5 mod 3 is just going to be equals like that. And again, you can just show this here, 11 mod 3. So we can convert to 5, or we can leave it as 5, and it's going to be the exact same thing, even though we're using a base 10 mod function with this OneNote calculator. We can double check with large numbers to see this is always the case. So if we have 1, 2, 2, base 4, this equals to 1 plus 2 plus 2, which equals to, this can be 11. And the question is, why is it 11? Well, this is 1 plus 2, plus 2. We're dealing, this is the v equals to. This is the v equals, we're adding the digits. This is going to be equal to 1 plus 4, which is 10. Yeah, so 1 plus 4 equals 10. And then add those up, the digits 11. Again, this is dealing with base 4. So that's why converting to base 10 is pretty good. But this one, just to show that you can just use it. Anyway, so equals 11, v equals 1 plus 1 equals 2. So 1, 2, 2, mod 3 equals 2. And now we can go, even bigger numbers. So 1 with 6 ones. This is v equals to 1 plus 1 plus 1 plus 1. This equals 2. Well, every 4, we add 10. So that's going to be a 10. So this is going to be let's put a 10 right here. This is 10, and then plus 2. So 10 plus 2 is 12 in base 4. And then this is going to be v equals to 1 plus 1 is 3. And then we could also go 1, 1, 1 mod 3. This equals to 0, which is v equal vortex sum is 3. Just set it to that. And now let's go even bigger numbers. 1, 2, 2, 3, 3, 2, 2, 1, 1. This equals to 1 plus 2, 2, plus, just add up the v equals 1 plus 1, 2 plus 2 plus 3 plus 3 plus 2 plus 2 plus 1. This equals 2. So every 4, let's just do, this is going to be 10. So let's, I don't know why I added this complex example. So 10, this is going to be 10. So just see how many 10s we have. This is going to be a 10, 1 plus 3 is 4, or 10 in base 4. And then we have another 10. We have another 10. And we have another 10 right here. So in other words, we just have 4 10s. So 10 plus 10 plus 10 plus 10 equals to, 30 plus 10, because we can't get a 4. Yeah, so if it's 40, the 40 just goes to 100. So 30 plus 10 equals to 100, v equals 1. And then you can just go mod, 1, 2, 2, 3, 3, 2, 2, 1, mod 3, and you should get a 1. Absolutely amazing. So amazing stuff here, guys. This is actually, this is pretty amazing. And that's why I do mathematics. That's pretty cool stuff. Alright, so anyways, MES note, all numbers used are by default in base 10 unless stated otherwise, and this is for convenience and uniformity, especially when we deal with random different number systems. So whenever I reference any number and I've not stated otherwise, then it will be in base 10.